Alright, welcome to the next chapter. And in here, we're going to work our way towards making an organic plant life structure using curves and motion paths. So here's an example of a few images that I searched for with Google to try and find some basic ideas for you of what it is that we're trying to achieve. Like something where we can build large quantities of objects with pretty refined control driven by curves so that we have this micro to macro kind of control, meaning that we can have macro or large controls to move large amounts of objects like the entire tree, and then also have this micro control where we can refine the rotation of a single plum at the end of a branch. So to do this and to help you get along there, get to that point, I'll introduce to you some of the tools in Maya that are required to do this. And then what I'll do is sort of segue towards some tools that I've written in MelScript and walk you through a little bit on how they work and definitely show you how to use them as the user end of it and to create these sophisticated structures. To get started, let's take a look at motion path in Maya. Right, so let's start with a curve. And let's make a CV curve in the top view. And let's bring in a cone, polygon cone, into the scene. What I want to do is attach that cone to that path and then have that cone follow the orientation of the path and even be animated along the length of the path. To do this, I would go to my animation menus and get a tool called motion path. It's called attach the motion path. So let's open up the option box for that. Okay, there's a bunch of different settings in here, and let's just take it from the default and see what happens. So we'll select the cone, select the path, and we'll hit apply. So right away, let's just close that for the moment. So right away, what we have here is an animation of the cone traveling along the length of the path over the course of 24 frames. So the default settings of the motion path is that it will take the time range that you have here and connect it to it and keyframe it as well. So we can see what the keyframing is in the attribute editor under the motion path tab, and this value highlighted in red, the U value, is the one that's animated, and we can investigate that by going to the motion path U value output, and in here we can see where it's keyed in time and what the values are. Okay, so at frame 1 it's a value of 0. 0, if you remember from my discussion on curves earlier, is the beginning of the curve, and at frame 24, or the last frame in our time slider, it's been keyed to a value of 1 or the end of the path. So the path is a length of 0 to 1. We can investigate this in the animation editor. If we go to Window, Animation, Graph Editor, and in here we can see the U value. If we just hit A to fit it up, we can see the actual motion path that's driving this object. So this is what you get in a default situation. You get this slow out, slow in curve traveling along the length of the path. So there's another way that we can use this. Let's say, given where we are right now, we could actually break this connection. So if I right click on this U value input and choose break connection, what I have now is the ability to manually, so the animation's gone, so you can scrub the time slider all you like, it's not going to go anywhere. But it is still connected to the curve. It's just that now you're in control of those values. So if I hold control and middle click and drag in this input field, there we go, and middle click and drag, I can drag this value. Of course it's very, very, very sensitive because it's such a small change. We could also use the channel box, motion path, U value, and use the virtual slider here. There we go, that's more refined. So we can manually control where this cone lives on the path. Now here's the other added advantage. We could go to the curve, go to control vertex, and manipulate any one of these points, and the cone will dynamically and interactively respond to it. So it is bound. It is called, in some programs, it's called constrained. So for every intent and purpose, this is constrained to the curve, and it has to follow that tangent handle. And we can even change the direction in which the cone follows it. So we can go to the attribute editor and go in here and tell it to actually follow on a different vector. So we're using world vector for the y-axis of 1.0 on the y-axis. So we could actually say 0 on the y-axis, but a value of 1.0 on the z-axis. And then we could go in here and change just exactly the direction of front and up, so that now when the cone travels on that path, so if we go back to the u value and we drag it, notice how it points along that path. And so as we change and dynamically change and shift the angles or curvatures of the tangent path, notice that the cone, and let's turn on wireframe so we can see this more clearly, notice that the cone is following the direction of that change. So pointing along it. So this is a technique that you would use if you wanted to attach maybe the lead train car onto the train track curve path, or the car on a curve, and the curve is assigned projected onto a surface, and then so you can match the car to the shape of the surface. These are all very good strategies, nice simple strategies to get these jobs done. Or you want text flying through the air, and you're making some 3D motion graphics for, you know, the spot at the Super Bowl or something. Well, this would be a great way to get your text attached to the curves. So the tricky thing in Maya is getting a lot of these things attached to the same curve. Through the interface, to my knowledge, and I've investigated this a lot in Maya, there's no interface way, UI way of achieving multiple objects and binding them all to the curve all at the same time, and even distributing them along the length of that curve. There is no simple way to make that happen. I would have to go through and take one cone at a time and repeat this process, attaching it to the path and changing its U value, and then go get another object and attach it to the path and change its U value. And you can imagine that this is a way, slowly, to build up like fruit along the path, hanging on the tree, or leaves on the path. But I have a better way of doing that, and I've written a Mel script to help us get here, and I've called it my path constraints tool, and it's based on my experiences from Softimage. So I've written a tool that sorta, kinda acts like what can happen in Softimage, working within the quirks of the motion path tool in Maya. So that's what I'm going to show you next. So let's just show off what this tool can do. And first, let's take a look at it underneath the general editors and the script editor. So when you open this up for the first time, try not to be too worried about like how much you're going to need to know on a technical aspect if this is your first time embarking in 3D software. I think it's going to be well worth your time if you choose to continue to work with Maya, and in a lot of cases, in a lot of places, in a lot of jobs, you will be using this program. So you should gradually warm yourself up to Mel scripting, because it will definitely set you apart from your peers and make you more employable. A couple of things to note about this is that underneath the history, I've checked this feature right here called line numbers and errors. So as things crop up, as problems show up, you get a log telling you which line the error has occurred. And that can give you some feedback on maybe what you need to do, or you can give me feedback on what I should do if you consistently get the same errors. You can tell me what line number it's shown up on. So the tools that I've written for you, I've given to you in a text file, and what I expect you to do is to highlight all of this code. So Control A and select it and copy it, and then come back over here to Maya and make a new tab underneath the command menu. And you want to make a Mel tab, and Control V, paste that in here. And at the top, I've listed some basic descriptions of what this can do and what the instructions are. So basically this script will attach objects to a curve. So all you have to do is select all the objects you want to attach and then select the curve last and run the tool. The selection order is the order of the objects on the path from 0 to 1 of the path you value. Works best if the curve is drawn from the top view, but it's not required, and that's because of this up vector problem I was having, but we can talk about that later. To use the script editor to make it a little bit convenient and easier for you to read, these buttons right here show you the history, so this is like a list of everything that's happened recently. This is the actual script editor at the bottom pane, and this is looking at both panes at the same time. Try not to hit the erase function for the lower pane unless you intend to completely wipe it out, because it's not undoable. Occasionally I will erase the history pane so that I can help me log things such as errors and other bits that I'm trying to repeat. I can log them right here to get a sense of what's happening underneath. And another tip when you're using this thing, for those of you who do know some programming, is to use this feature right here called echo all commands. So not everything you do in Maya is going to be logged unless you check this to echo all commands. That's all I'll say about that for those of you who are willing to investigate it. That's about it, and you notice that there is Python support here, so for those of you with that experience you can use Python. So let's give this thing a try. And I'll just tuck it down here. And let's draw a curve in the top view. Something like that. And we'll get a torus to start to example this, and let's look at an outliner. And let's have, that's just number 8 on my keyboard. I changed that shortcut for number 8. And we'll do several duplicates. So let's just start with duplicates. So selecting all of them and then control selecting the curve last, or on a Macintosh, Apple selecting it in the outliner. And then what you should do is simply highlight all of this and hit play, and it'll run the whole thing. So notice that within less than a second, it's attached all of these objects to the path, and a couple of different things have happened. So let's investigate what this tool has done. So let's look at the outliner to find out what it's created for you. On the inside here, it's made a series of groups for you, and so what it's done is it's stacked groups similar to my double grouping stacking idea, except what we're going to do in this scenario is stack even more groups eventually. We'll get to that in a minute. But what you have here is a motion group, and that's the one that actually has the motion path constraint assigned to it. That one actually has the motion path parameter right here. The torus itself has nothing bound to it, no constraints to it at all, meaning it's a child that is freely movable within its parent space. So that means that if you want to offset this torus to the side a little bit, you can translate it in object space. I recommend object space, and you can move it anywhere within its parent space, and it will still be attached at that location. So you can modify the overall look of this, and all of them will dynamically shift. And notice how they're all reacting to it. They're all kind of evenly spacing each other out. That's because the U value is a percentage. So they're all bound to their location on the curve at a specific percentage. And that percentage, in this case, is cut up based on the number of objects that I've created, and they're evenly distributed along the length of that curve. So if you don't like the distribution of, or the even distribution of them on this curve, or you want to compress them on either end, I've added this extra object for you, which is this curve offset locator. And so when you translate this locator on the x-axis, it will actually compress all of them at one end, or go the other way as well. So I added this little thing specifically with the intent for those folks who were making toys or objects that had multiple objects on a path, like a necklace, for example, where you have like pearls, and then in between each pearl is maybe a metal stud or beads, or you know, like beaded shoelaces for those of you with those cool things. So this is a way for you to stack multiple objects on at the same time. So let's take a look at how that might work. So I'm going to delete these bits, and we'll start this over by creating a few more objects. But just before I show that to you, I wanted to enlighten you on what's happening under the hood. Just one more thing before I go on to the multi-beaded example. if in the outliner you check this little feature right here and turn it off, this DAG objects only, turn that off, you'll see a huge list of all the different objects that have been created in this scene. And what's really important is that there's this motion path U value object that's created per object. That's how I was able to successfully attach many objects to the path, is that I basically repeat that process over and over again of applying a motion path per object. And each object gets this U value node. So if you are running a lot of experiments and you're kind of creating and deleting objects, keep in mind that there's this U value object underneath that are adding. So these don't go away. So you need to manually go in here and delete them. And there's also an expression that gets created along with it, because that's part of the tool. You can delete that expression object as well, and then just leave everything else alone. And then you can turn your DAG objects back on, so you're only looking at the sculptable objects in the scene. I hope that makes sense. If not, play with it a little bit more and you'll see. So let's try another example, and we'll stack up like 2 different types of beads on the same path. Alright, so let's do this with toruses, and we'll do it with cylinders and toruses. So let's begin by making instances of this torus. So we'll group it twice. So we'll use the same strategy we have used before, and I'll go to your Edit, Duplicate Special Option box. Let's reset the settings that are in here. We want to make instances. We don't want to make new groups this time, and we're going to leave them right where they are, and we're going to make maybe a total of 10 copies. So we've got 1 plus 9 more. So they should all have that group 1 instance underneath it. So we'll select the top one, hold shift, and select the bottom one, so they're all selected in that order. And then we'll control select the curve, so the curve's highlighted in green, it's the last one selected, and we'll hit the play button. And so they're all going to get attached, and if we dig underneath here, so we've got this master group, and then the top level group per object, which is the motion group, that's the one that has the motion path on it, and then we have my group with my instance group with my instance object. Okay, so if I want to add more objects to this scene, I would simply add it to this torus object. So let's add a pyramid to the scene. If I wanted the pyramid to be inside the torus, it's just a simple matter of middle click dragging and dropping the pyramid onto group 1. And notice I get a lot of instances, and they're kind of like scattered all over the place. They don't quite know where to go. That's simple enough. Basically, we just have to tell it to snap to its parent. In order for it to snap to its parent, we need to set its translations and rotations to be 0. So highlight all of those, enter 0, and then hit enter. And notice that they all snap to the center right where their parent is. So that's a pretty simple solution. And we can see that that new pyramid has been instanced into all of the other pieces. So next we want to add a cylinder that's kind of in between these pieces, or maybe a sphere. Let's use a sphere. We'll use the same strategy. We're going to group it twice, and we're going to instance it the same number of times. We're going to select the first one, shift select the last one, control select the curve, and we're going to run my script again. So now notice that they're still all stacked in the same place because we use the same number, but now I can grab this offset tool and drag it backwards a bit and have great control over their placement in between each one. So I think this is fantastic. It really has worked out well. If I wanted to continue to model and animate the curve, I can select the curve, go to CVs, and tag those CVs. Actually, it's even easier to tag CVs if you just go to your component filter right here, turn off everything, all components off, and then just turn on NURB CVs. So now the only thing you can select in the scene are NURB CVs. So now you can go through making changes, sculpting, and shifting. So this should really get you thinking in different ways about how to model from rigid objects to organic pieces. I think that this will really shift how you be thinking about it. Notice I can even grab the last CV or the first CV, change the total length of the curve, and everything else responds and evenly distributes. So there's no squash and stretch in this scenario. Everything's rigid. It's bound to a certain point. So this is not like some kind of flexible spine solution. You'd have to do a bunch of other things for that. This is really just for the purpose of distributing and assigning objects to a curve in mass, and in this case, with this added feature of being able to stack multiple pieces on it. And let's take a look at another scenario where we have leaves on the path, and you've worked out a texture where the leaf stem is at a particular point, and you want to like snap that stem right to the base of the curve or right onto the path. Let's take a look at a scenario like that. Well, I'll forego the texture. We can add that later, but I just want to go through the pivot point process. So again, a CV curve from the top. And here we've got a plane. And let's make this plane a little bit narrower. And let's make it like narrow like that. And let's give it just one division, so very simple polygon. We can do this by the grouping method, where we have the pivot point where the stem location is going to be right at the origin, or we can move the pivot point ourselves. So we can, I built it into the script so that if you edit the location of the pivot like this, and simply create a series of instances from that, and then run this on the path, what it'll do is it'll assign those objects at that pivot location. And here's something else that I may not have been entirely clear on, that there's actually a job and a reason for this stack of objects. So I didn't do the group method before actually assigning this. So what I have is a motion path group that handles the motion path, and then this master group that holds it all, and then the plane itself just sort of sits there. Well, the plane can move wherever it needs to move, including rotate and scale wherever it needs to rotate and scale. So I can do, grab all of these things and rotate them in their local space. Make sure I'm actually animating in local space. So I can grab all this stuff and animate them in their local space, which is the same as saying in their parent space. And then there's also a little bit of tools that I created to help maybe randomize the way these things are moving. And let's go get that thing. So here's a little script that does something very, very simple. What it's going to do is it's going to look at all the nodes that we have selected, and it's going to randomly rotate the rotation on X, the Y, and the Z. So we can actually govern, exactly how much rotation that's going to be and which rotations are going to move. So we can copy this, bring it into Maya. Let's make a new tab, mail tab, and paste that in there. So let's investigate our leaf and find out, what rotation do we really want to move this on. So we want to pivot on the y-axis to make some changes here. So instead of the x, let's just take that out completely, just delete it, and not the z. So, and it's going to randomly change it between 0 and 360. So if we run this on our selection, so make sure we select the actual objects and not the groups, and we play this, you can see that, and we just keep playing it, we'll get random numbers all the time, but they're always going to be at the pivot location, staying right there on the path. So this is a nice, very, very nice way to, in one hand, use the path to bind them and get them in place and control them in bulk. And on the other hand, we can go in here and just start tweaking some different settings. And we can do the same thing on scale and translation. So scale would just be a slight modification of what we have right here. So let's take a look at what scale that we'd be trying to change. So in this case, it would be the X scale if we wanted to scale upward or outward. Maybe the Z scale, but Y scale will do nothing because it's flat on the Y. So X and Z would be the two scales that we want to change. So we can actually take this little bit of code that we've already got, copy it, go into another new tab, mel script, paste it in there, and we just change the word rotate for scale, and change Y for X, and then we can even copy that little bit, put a comma in there, space it out here, and then make it Z, something like that. And it's not going to be a random value between 0 and 360 because 360 would be 360 times larger for a scalar value, but we want something like 0 to maybe 2, so twice as long. So all the way from 0 to 2. So we can't really scale down to 0 either, otherwise we'll get nothing. So let's make it maybe 0.5. So 0, so 0.5 to 2.0, something like that. And this is going to produce some neat changes. And let's just filter everything off and only select polygon surfaces, so that way I can just mass marquee everything. So when I play this, notice that I'm getting these random changes between scale on X and Z between 0.5 and 2.0. And I can go back to my rotation tool and maybe even adjust that a little bit. And let, even adjust and say, well, maybe I don't want a full range of 360. Maybe I only want to randomly rotate between 0 and 90. And so it'll constrain that within 0 to 90. So you can see now they're all forced within 90 degrees. So, if I want to give the impression that all of these leaves are blowing in that direction, but randomly, I can force the random rotation in that direction. So let's take a look at this just one more angle here. So what if we didn't just instance geometry or objects along the path, but we also instanced curves? So let's take that idea somewhere. I'll draw a CV curve. We'll keep it simple, and I'll snap to the origin, and we'll make it 4 points. So just something easy for this. And I'll group that twice. And since the first point of this curve is at the origin, when I group it twice, both of those will also be at the origin. So all of its centers are aligned. This is very useful. Very useful for keeping the curve constraints predictable. And I will instance this curve with the same strategy with the duplicate special. No transformation changes, just instancing, and I want 9 of them for a total of 10. And we take those groups and constrain them to the path the same way. So we'll select all of that and hit play. So now I have all of these curves. Probably a bad idea to instance them because now they're all going to be the same shape. But if I hadn't instanced them, I could then sculpt each of these different curves and have them connected to the original one. Let's turn on curves. And have them connected to the original one. So let's just backtrack half a second here. Draw another curve. And CV. Snap to the origin to start. Keep it simple, 4 points. And then group it twice. Go to duplicate special. Copies, not instances this time. Hit apply. Select all of those. Control select the curve so it's the last one selected. And run the tool one more time. And now I've got a bunch of curves that are individuals. So I can model these. And let's just turn the filter to components and turn the filter to NURB CVs only. So I can just grab any CV at any point and move it. So now I have this ability to model the curve. And notice how I can get changes to all of the others as well. So this just is fantastic. So when you start getting into sophisticated problems where you need to like stack curves on top of curves, this is a pretty cool way to go, and you get a very modular setup. Meaning modular or procedural, meaning that even if I wanted to do something like select all of these and loft between them, that option is there. And still have this control over the original curve, and go back to components and be able to get these changes And then on top of that, I've got curves in a tool where I can just start binding things to the surface. So, you could imagine like the cat that I made, and we've got the saddle, and I can go back to the saddle of the cat and start putting on like little metal studs for where it was riveted together or something like that. Or maybe I wanted to create my own kind of stitching pattern, and then bind that stitch pattern along the length of the path. So there's all of these very powerful uses for this sort of work, and having a couple of tools to help you get there, to help you get started, is all you really need. So, let's take the idea of the scaling and changes on scale for the curve. So the curve is one-dimensional, more or less, and let's go back to objects, select the curve, choose scale. So really I'm changing mostly the Z. There's little to no change on X, and little to no change on the Y-axis. Should be no change on the Y-axis, in fact. And that's on the object itself. So if I go through and just filter off everything except curves and run this, now I've got some scale changes per curve. I have no idea why, but that's kind of interesting. And from here, I would take that surface and do the conversions and thickening and go through all that stuff. Really quite fantastic having this added ability sitting right here at your fingertips, and all the while, even with all that stuff connected to it, I can still go back to the original curve and make some changes. Go through here and say, well, I want that. So this would be a handy way of maybe doing sophisticated thick cloth-like pieces that without the dynamics, or maybe with the dynamics, I don't know. I would be able to animate big, thick, large, bulky pieces of geometry based on thin two-dimensional curves. So something to kind of get the creative juices, imaginative juices flowing, and definitely something for us to use to solve some of the more complex problems that we're running into in the past. Like the spiraling staircase, for example. Let's take a look at a situation where I might be able to utilize this with linear curves. Alright, now let's see what the path constraint can do for us if we were to go back to the stairwell, and how that can empower us. So let's create a 2-point linear curve. I'm not going to make the entire stairwell, I just want to get it started so I can show you how this might be done. I'm going to draw a 2-point linear curve, 10 units tall, starting from the origin. And then I'm going to bring a box into the scene. And I'm going to instance that box several times. I'm not going to transform it. And I am going to rotate it. Let's do the standard that we did earlier, 26.8 degrees for 12 steps. And we'll take all of those and select the curve last and run the path constraint. So that's really cool, because what we get essentially is the ability to adjust the height of this stairwell without having to go back and rebuild the entire spiral. So we can basically change the riser between the steps. And I really like that. This has got some serious advantages, and worth looking into. Another thing to notice too is that when the I draw from the front view, that the up axis is not quite right. So what happens is, if I translate this vertex and change the plane that this stairwell lives on, it'll start freaking out. So if I move it down, you see how it flips? So the problem here, and it gets worse on a curvy stairwell. So if I made like a 4-point CV curve and made a stairwell and had like an organic shape to it, kind of like an MC Escher style, that would cause all sorts of flipping. So there's a way to change the up vector for the motion path. And if we go underneath the groups that were created by the script, the motion path group, the motion group, is the one that actually has the motion path assigned to it. And in here we have the world up vector set to y-axis. So we could go in here and manually change each one, but that could take some time, especially if we had more than 12 steps. So the way to do this efficiently and without scripting is to go into hypergraph connections for all of the motion groups and take a look at this. There should be a column right here of all the motion path objects. So you want to select all of those nodes, and then you want to go to your attribute spreadsheet, and it populates the attribute spreadsheet with those motion path objects. You can also see what the U value of each object is. Well, there's an All tab over here on the right hand side, and if you scroll to the right hand side a little bit, you see world up X, Y, and Z. So if you highlight the column and enter 0, you can zero out the world up Y, and if you highlight the Z and enter 1 and hit enter, you can then flip the up axis to world Z. So it's a couple of steps, but at least you don't have to go into MelScript to make it happen or do it one at a time. So you've got an attribute spreadsheet where you can change all of those attributes all at once. And I'm sure you could find some uses for the attribute spreadsheet when you want to change a whole bunch of objects that all have the same property all at once. So let's take a look at this example with a curvy curve. So let's go to the front view again, and this time draw a normal CV, cubic 3, and we'll draw a 4-point curve. Actually, let's do a 6-point for the fun. Have a little fun with it. And we'll bring in a cube, and we'll group that cube. I'm just going to group it once. Makes it a little bit easy to manage. And when you group it once like that, thinking about those videos a little while ago during the stairwell process, the cube is the only one that gets the instance. The group doesn't get the instancing. So it becomes a bit easier to manage in that regard. Let's make 24 steps, total of 25. Just have some fun, have a couple of rotations. And I won't change the y-axis. The curve will take care of that. And instances. So and we don't need a new group to manage them. So we'll take all of those groups and control-click on the curve there in the outliner last, and then run this tool. And like magic, or almost like magic, then we'll go in here and grab the first group and just translate it to the side. We'll grab the cube, and translate it to the side. And you can see how the curve does present some problems when the up axis is set to the y axis, which is the default for the motion path. See how it's like broken right here, broken up here. So we want to fix that. So we're going to select all the motion groups. Make sure these are minimized when you do your multi-selection. So it's just the motion group selected. Then you're going to go to the hypergraph connections, and you're going to select the column that has the motion path. Should be this column right here. And the last one, there we go. Then you're going to go to your attribute spreadsheet. Under the general editor's attribute spreadsheet. And you're going to go to your All tab and just scroll to the right hand side. Change the world up Y to be 0 and world up Z to be 1. And notice how it's been corrected. See that? Look how beautiful that is. So it really does make a difference. And this is kind of a nice tip for you too if you ever get to character rigging. When you're rigging the spine for a character, that the up axis in Maya is actually going to be the Z axis when you're constraining things to a spine curve. Something to keep in mind. So now when I make modifications to the actual shape of this stairwell, you see it's actually quite stable. Again, as long as I don't break the plane, like if I go into, meaning when I say break the plane, I mean if I like totally contort it way over to the completely different plane, it's going to be reasonably stable for a little while, and yeah, so now it's starting to jump. And yeah, it's not too bad. Of course it'll break if you fold it onto itself. It'll start to break. It's starting to break in here. But really, really good to know and understand that up axis, and also that the distribution of your CV points and the sort of the smoothness from one CV point to the next really does make a difference in quality. And then, to sort of enjoy the fruit of your labor, and to see, is this thing really holding up? Are we really holding up here? Let's take a face, just one face here, and translate it to the side, and maybe thicken the step a little bit and get a sense of, are we spinning in the right way? And it appears to be pretty good. I am contorting this over in a big way, but I think this will work very well. So, attribute spreadsheet, connections to change the world up axis on all of these objects, and you get pretty good results. So keep that in mind as you go.